Let me see the concept of the project. Efficient method for event detection in phonographic signals. Heartbeats are usually used to analyze the heart qualification. Cardiologist performance are calculated based on the heartbeat rate. In this project, we use the novel approach to calculate the heartbeat peaks. We detect the peaks using PCG signals. PCG signals are given as an input and then perform the feature selection, feature extraction process for that project. Initially, we perform the low pass filter and performing Butterworth filtering process, and we also calculate the error detection in this project. We extract features like systolic and diastolic spaces. These intervals are calculated and the peak difference are calculated. The peak, based on the peak difference, we extract the features. From that features, we select the best feature among that using the genetic algorithm. Genetic algorithm is used to select the best feature among the intervals, and then we perform the KNN classifier to classify the result. This result classify the murmurs and normal heartbeats from the given query image. Before we performing the training process to all the PCG signals and performing the classification result. Let me see the flow of the project. Efficient method for event detection in phonographic signals. In this project, we performing the two processes, one for query PCG signal and another one for database PCG signal. Load all PCG signal and performing the low pass filter. Low pass filter is performed for order 1, order 2, order 3 process and order 4 process. After that, we performing the pre-processing. Pre-processing is the basic step in image processing. Pre-processing is done by Butterworth filter. Butterworth filter the PCG signal, and that is clearly used for feature extraction. Before that, we detect the error rate, which is usually normalized, and then performing the feature extraction. Feature extraction in the sense we performing the systolic and diastolic intervals, and we also calculate the peaks and peaks difference from the PCG signal. These are the features are considered for this PCG signal. After that, we store the PCG features. PCG features are used for feature selection process. Feature selection is done by GA, genetic algorithm. Genetic algorithm select the best features and displays the features. These features are used for further process. Trained and non-trained feature values are stored. Then we performing the matching process for query image. The query PCG values are matched with the training features by KNN classifier. Then KNN classifier matched labels are returned as result, which is the PCG signal is normal or abnormal. Let me see the running procedure of the project. Efficient method for event detection in phonographic signals. Right click on the main.m function and press run file to run the program. That shows the execution window. This is the execution window. Initially press train all button. Train all signal. It load all the signals and performing the feature extraction, and it also performing the feature selection process for the all the signals in the data set. After that, we perform the load up signal process. This button performing the query signal that load the one PCG signal that is done by user at the time of runtime, and we are selecting any one signal from this. We also give the trained or non-trained images. The inputted signal is displayed, and this detailed length of the image is displayed in the next axis. The low pass filtered order 1, order 2, order 3, order 4 values are displayed. Low pass filtered PCG signal is displayed in separate axes. Then we have to perform the filtering signal process. This the filtering process is done by Butterworth filter. Butterworth filter is done and it displayed in the separate axis. Butterworth filtered image is displayed in the separate figure. After that, we performing the error detection. The error detection is calculated and is displayed in the command window, and the detailed minimum error detection is displayed in the separate figure. After that, we perform the peak detection. The peaks are calculated and denoted in the separate axis. This is the power frequency plot for the given PCG signal. The S1, S2, the two signals peaks are detected. The separate peaks are denoted by different colors, and we also detected the peaks of separately in the separate window. Diastolic and systolic intervals are calculated in the feature extraction. Then pressing the feature extraction button, it extracts the feature for query images. In this feature extraction, we calculate the features like mean S1, mean S2, average systole and average diastoles values, and the average systole and diastole values, standard deviation of the S1, standard deviation of S2, standard deviation of N1, Nn is the systole and diastole values, RMMD value, and the low frequency, high frequency, very low frequency values, and the sums are calculated. And we also calculate the peak values of the given PCG signal. We also calculate the difference from the systole and diastole values. This difference are calculated. Based on this difference, we classify the result, and we also performing the feature selection. Based on this feature, we calculate the separate features. This decides the best feature values. The features are selected and displayed in the selected feature table. After that, it displayed a message. Training features are extracted, and then we perform the classification process. Classify button is displays the classification result. This classification is performed by the KNN classifier. KNN classifier match with the training and test selected query features are matched with and displayed the message. Feature selection is done by GH, that is genetic algorithm method is used to select the best feature among the features and classify the result. Thus the result is normal. After that, press the exit button to close all the and exit the process. Thank you.